Alright guys, next section in our first section in our next unit that we're going to test, transformations part 1. So we're going to look at 3 types today: vertical shifts, horizontal shifts, and then 2 types of reflections, the x-axis, the y-axis. Okay, your part 2, then we'll talk about vertical and horizontal stretching and shrinking. So before we do our actual transformations, we need to remind you about the parent function. So you may want to write these down, in particular the graphs, because these are what we're going to be changing. You're going to need to know these. So absolute value function means y equals the absolute value of x. You also see it right here, and our graph would be a v, like this. Okay, I'm going to go through these pretty quick. Let's see, then we have our standard quadratic, so we have y equals x squared, and that's just going to give us a parabola with a vertex at the origin. We have a square root function, which is half of a parabola but turned on its side. The square root, we want just the plus, not the minus, otherwise we wouldn't be a function because we failed the vertical line test. Standard cubic then is going to have just a little curve to it, and our reflection point is at the origin again. And so that brings us then to our first type of transformation, which is going to be a vertical shift. It obviously moves the graph up or down. There are 2 ways we can move it. We can move it up or down. If we have plus c, then that tells us we're going to move the graph up c units. And if it's minus c, then that tells us we're going to move the graph down c units. Now the way this is written here, what that means is that f of x here is going to be some parent function. Okay, and the plus c has to be outside the parent function. It may make a little more sense after we talk about horizontal shifts as well. But an example of something moving up, we could say would be f of x equals x squared plus 2. This would be up 2 units, and you see that the plus 2 is not inside the parent function. It would be inside, also being squared if it was. An example of moving down, we could say would be f of x equals the square root of x minus 4, and this would be down 4 units. Okay, the other option we have then, or actually an example first. So you see here we have our absolute value function drawn already. This is telling us to move down 4. So if I clone that, I'd move it down 4 by going 1, 2, 3. This would be down 4. Let's see if we can change that even. Okay, so our new graph would be down 4 right there. Okay, and if it was up 4, we just go the opposite direction, obviously. Okay, the other option then is a horizontal shift, which is a movement left or right. That's f of x plus c, and you'll notice now that the plus c or the minus c is inside the parent. Okay, and the other thing to keep in mind here is that when we're doing horizontal shifts, things are opposite. So if it's plus c, that actually means we are going left c units. If it's minus c, that tells us we're going to be going right c units. So the way that is different from our other one, we could keep the same, and we're going to do x squared again. If we say plus c now, you'll notice, or I'm sorry, plus 2, you'll notice the plus 2 is inside the parent function, meaning it's also being squared. So this would be left 2 units instead of before it was outside and it was up 2 units. Okay. Similarly, if we say the square root of x minus 4, you'll notice the minus 4 is also under the square root symbol now, so that tells us that we are going to move right 4 units. Okay, so if they are part of the parent function, inside the parent function, it's horizontal. Outside the parent function, it is vertical. Okay, an example of this one, again, if I clone this here. Okay, so the plus 5 tells us to move left 5 units, so I'm going to count 5 units over and get my new function. Okay, I can make that in red again. That x plus 5 would be in red there. All right. Then we could also do multiple ones. So this would tell us to go left 1 and down 3. Okay, now I wrote left 1 down 3 first because I'm working my way inside out, and that's the way we want to do these. Always work inside out. It's kind of like order of operations. Start in your parentheses, then you do multiplication, so on and so on. Alright, so left 1 down 3. So if I take the function that I have here, x squared, and I put it back where it started, I'm going to go left 1 and then down 3. And again, I can change that color. so that I see left 1, down 3. Big thing being there that we changed our vertex from 0, 0 to negative 1, negative 3, which is left 1, down 3. Okay, let's see then. Our last piece we're going to have is about reflections. So again, when we do negative f of x, that means we're taking our parent function and we're reflecting across the x-axis. So outside, negative f of x is outside the x-axis. If we plug in a negative x, meaning we have a negative sign inside our parent function, that is going to be a reflection about the y-axis. And I'll show you each of those here. So you'll see that this is outside the parent function. If it was inside the parent function, it would be negative x cubed. Okay, and we actually have a mistake here. Okay, and all right. So this is actually what our graph should look like if it was x cubed. Get rid of a few points here. Okay, so this would be x cubed. And we want to reflect across the y-axis because it's outside. So keep in mind, we're not doing that one. We are doing this one outside. So we're reflecting across the y-axis, which means we're going to take this, and if I clone it again and put it there, across the x-axis means you are flipping it up and down. So it should look like this. What was up should now be down, and what was down should be up. So this piece right here, this piece came down and this piece below came up. Okay, now don't think of it as rotating. That didn't rotate, it just flipped across the x-axis. Okay, the other option then you'll see here, now the negative sign is inside. Okay, so I have square root parent function here. So if I clone it again, we are going to flip this across the y-axis. So inside is across the y-axis. So I'm flipping that then left and right, and across the y-axis should end up over there. So that is going to be our new function. Inside tells us flipping across the y-axis there. Okay, so that is it for this lesson. We went over vertical shifts, which remember means it was inside, or I'm sorry, it was outside. We're moving up if it's plus c, down if it's minus c. Horizontal shifts, everything was inside, and it was also opposites. Plus c means you move it to the left, minus c means you move it to the right. And then we had two kinds of reflections. If the negative was outside, it was across the x-axis. If the negative was inside the parent function, it was across the y-axis. All right, see you next time.